All right, guys, for this problem, it says a conical paper cup is 30 centimeters tall with a radius of 10 centimeters. The cup is being filled with water at a rate of 16 pi over 3 cubic centimeters per second. How fast is the water level rising when the water level is 8 centimeters? All right, when I put this paper down, it's going to change the focus a little bit, so I'm just going to reread some of this. All right, basically what's happening here, guys, is that you have a conical paper cup. So if you can imagine a cone-shaped cup, and it has a height of 30 centimeters, and it has a radius of 10 centimeters. So there's the radius and the height of of the problem. I know it's kind of hard to see. Okay. All right. It also says that the cup is being filled with water at a rate of 16 pi over 3 cubic centimeters per second. So that means that the volume is changing at that speed. So dV over dt is equal to 16 pi over 3. It also says that the instant that the height is 8 centimeters, so when the height is 8 centimeters, how fast is the water level rising? So it wants to figure out what dH of dt is when the height is 8 centimeters. All right, well, the only formula for a cone that we have is volume equals 1/3 pi r squared h. But if you notice, they don't give you the length of the radius in this problem. So what we're going to need to do is we're going to need to rewrite this formula without the radius. So we're going to have to basically plug in a value for the radius. Well, then you're probably thinking, well, how in the world are you going to come up with that value? Well, if you look carefully right here with this cone shape, if the height of it is 30 and the radius is 10, do you see how that forms a right triangle with, let me write it over here so you can see it better, with a height of 30 and a radius of 10. So you could really set this up as a similar triangle, right? The height is 30 and the radius is 10. So let's cross multiply and you get 10h is equal to 30r. Now remember, you want to rewrite the radius or rewrite r. So I'm going to solve this for r. And that's going to give me the r is 10 over 30. That reduces down to 1/3 h. So what I'm going to do is I'm going to substitute that value of 1/3 h into the radius. So let's see what that looks like. Volume is equal to 1/3 pi. And then the radius is 1/3 h. So 1/3 h. Don't forget squared. Times h. So let's clean this up a little bit. So I'm going to get volume equals 1/3 pi times 1/3 h squared. That's going to be 1/9 h squared h. And then I notice 1/3 times 1/9 is going to give me 1/27 pi h cubed. All right, so now we can take the derivative implicitly, right? Do the implicit derivative of this function. So the derivative with respect to time of v would be dv over dt. This is a coefficient, so I'm just going to have 1/27 pi, bring that out front, and the derivative of h cubed would be 3h squared dh dt. Now remember, the problem wants you to find what dh dt is, but it gives you dv dt and it gives you the height. So let's just go ahead and substitute those values in. So dv dt is going to be 16 pi over 3 equals 1/27 pi times 3 times 8 squared times dh dt. All right, so I've got to do my arithmetic to this now, work it out. So let's see where I can start. 8 squared is 64, and so I can also go 64 times 3. So let me multiply that. 64 times 3 is going to give me 192. So I'm going to have 16 pi over 3 equals 192 pi over 27 dH over dt. And then to solve this for dH dt, I'm basically going to divide this whole thing by 192 pi over 27. So 192 pi over 27. And this is a complex fraction, so state change flip. So I'm going to have 16 pi over 3 times, flip this, 27 over 192 pi. And then that's going to give me the answer to the change in h over t. What I notice is that my pi's will cancel out. And so 16 times 27 is 432. So this would be 432 over 3 times 192 is 576. But I hope that that will reduce 432 over 576. It does. It reduces to 3/4. So basically, the change in height with respect to time is 3/4, and it would be centimeters per second. So in other words, the height is increasing, right? It's increasing at 3/4 centimeters per second, and that would be the answer.